Good morning to everyone. My name is Venkateshwar Rao, lecturer in computer science, Government Polytechnic for Women, Pebble. Today topic is compiler, assembler, and structure of C language and executing a C program. First we see the definition of compiler, assembler, and interpreter. So first of all, what is the assembler? So assembler is a software that converts assembly language program code to machine language code. That is called assembler. It converts the assembly language code to machine understandable code. That is called assembler. And this compiler, it is also a software that converts the program written in high level language to machine language. Compiler converts the high level language to machine understandable language. High level language is in the form of English text language. Here we use English words and phrases. Okay, the compiler converts this high level language to machine language. See next, interpreter. So interpreter is similar to compiler, but it converts the instruction one by one. Compiler converts the total program at a time from high level language to machine language, but in the case of interpreter, it converts the instructions one by one, one after another instruction. That is called interpreter. Assemblers and compilers plays an important role in execution of a program, and some compilers directly generate the executable code instead of assembly code. Okay, so these compilers and assemblers are the softwares, and these two will play the important role in executing the program. The compiler takes the preprocessor source code and translates it into assembly code. So it takes the source code, compiler takes the source code, and then it translates it into assembly code. The assembler takes the assembly code. Here in the assembler case, it takes the assembly code from the compiler and then it translates it into machine code. This is relocatable machine code. So this is the diagram. Okay, so this shows the translation of high level language to assembly language, again then into machine language. The compiler converts the high level language to assembly language, and assembler will take assembly language as input and converts it into machine language. So machine language which is in the form of zeros and ones, and high level language which is in the form of English like words or English like phrases, and assembler or assembly language which is in the form of mnemonics. The instructions are in mnemonic format. Next, assembler, the process of converting assembly language instructions to machine readable form is carried out by program called assembler. So assembler simply converts the assembly program or assembly source code to machine code, and the machine language is sometimes called object code, or we call it as object program. The assembly language program ALP that is given as input to the assembler is called source program, and the output of the assembler is called object program. So this is the source program, it is assembly program, and his output is the form of machine language. This is also called as object program. So there are different assembly programs available in the market. It is TASM, Turbo Assembler, and MASM. It is the macro assembler. These are the examples for assembly programs. So next is the compiler. So the compiler, it translates the high level language to machine language. Okay, and this requires an intermediary program called translator. So compiler use translator to convert the high level language to machine language. The compiler and interpreters are two translator programs that are used to translate the high level language program into machine language. So here also the program written in high level language is called source code. So the program which is written in high level language is called source program. The corresponding program after translating is called object program. The output is called object program. So here, so this is the high level program or high level language. Here the compiler translates it into machine language. The high level language program to machine level language conversion is shown in the following figure. So here this is the source program. It is compiler. It translates it into machine language, which is also called object program. Let us see the differences between compiler and interpreter. So the compiler, it takes entire high level language program as input and translates it into machine language. It takes the total program and then it converts it into machine language. It takes the entire program as input and then it translates it into machine language, which is its object program. Whereas in the case of interpreter, it takes one statement of a high level language program as input. So here it converts the program statement by statement. It takes one statement and it converts or it translates it into machine code or machine language and then it executes the statement. Here it converts the total program at a time. Here it takes instruction and then it translates it into machine language code. And second difference is all errors that occurs in the program are listed and displayed. Here at a time all errors are displayed, and in the case of interpreter errors are occurred only in the statement being taken for translations are displayed. So here if the statement or one statement is having error, then that statement is only displayed. The reason is it takes one instruction or one statement at a time. And the third difference is debugging is faster. So debugging is nothing but finding the error, okay, and overcoming the error. So this is faster in the case of compiler, but in the case of interpreter, it is debugging is slower. The reason is here we translate the code from high level to machine language, okay, in the form of, or we call it as the statement by statement. Here the process is statement by statement process. So the process is slow. And the fourth difference is it requires more memory. Compiler requires more memory, and in the case of interpreter it requires less memory. And compilers are costlier to design and interpreters are cheaper to design. So this is the differences between compiler and interpreter. So let us see the structure of C language. So this is the structure. It is having three parts: part 1, part 2 and part 3. So in part 1 it is having the documentation section, link section, definition section, and a global declaration section. In part 2 it is having main method. So it is called main method or main function. And the third part is having user defined functions. So this is the structure of C language. First we discuss about this first declaration, that is documentation section in part 1. So documentation section is used to write the detailed about the program. Okay, it gives information about the program. The documentation section gives information about the program, like name of the program, author of the program, and the time when the code is written. Okay, and its features. Okay, it gives information about the program. Documentation section gives information about the program, and the documentation section begins with slash star symbol and ends with star slash symbol. So this is called slash star, and starts with slash star, ends with star slash. Okay, whatever you write between these two symbols, it is called documentation section. That section is called documentation section. And the lines which are written in documentation section cannot be compiled. It is only for user purpose, user understandable purpose. And documentation section is only for user or programmer understandable purpose, and documentation part is not compiled and executed by the compiler. Compiler will not execute the statement or line which are written in documentation section. And next we discuss about link section. So link section is the second part of that is the second thing in the part 1. That is the link section. So the link section provides instruction to the compiler to link functions from the system library. So it gives the links or link functions which are from the system library. And here general syntax for the link section is include, this is the less than symbol, this is the greater than symbol. Between these we will write the header file names. So here the statement begins with hash. This symbol is called hash symbol. Okay, are called the preprocessor directories. The statements which are starts with the hash symbols are called preprocessor directories. So this is the link section. And third one is the definition section. Definition section. See, the definition section defines the symbolic constants. Here we will define the symbolic constants. And general syntax is, so here this is the general syntax. So hash define null 0. So this says the null value is having 0. Okay, this is for defining symbolic constants. So null is equal to 0. The null value is 0. Another example is hash define pi 3.14. So this is for defining the symbolic constant pi. Pi value, we know that pi value is 3.14. 22 by 7, that is 3.14. So these are used for definition section. And this is a global declaration. See, there are some variables that are used in more than one function. So in programming, there are some cases that the variables are used in more than one functions. So such variables are called global variables. The variables which are used in more than one functions are called global functions, and whose existence is known throughout the program, and this declaration should be made before main function. So this declaration, global declaration, is made before the main function. So if you observe here, the global declaration section is made before the main function. So this is the example here. So these are the global declarations. Int a comma b comma c ends with semicolon. So integer is the data type and a b c are the variable names. Another example, float x comma y comma z ends with semicolon. Float is the data type, x y z are the variable names. And similarly, character space name of 20. So this is the array. Name is the array with the size 20, starting from index 0 to 19, and it is a character data type. So this is a global declaration section. So next is the main function. This is the main function. See, has the name itself indicates that so this is the main function of every C program. So every C program will have the main function, and execution of C program starts with main. The execution starts from main, and no C program executes without the main function. If there is no main function, then C program will not execute the program, and every program will contain a main function. This section contains two parts. So again, this section will contains two parts. One is declaration part, and the one is the executable part. Okay, so this is the declaration part, and this is the executable part. Main function will hold two parts: declaration part, executable part. So the declaration is a part of C program where all the variables, arrays, functions are used to be declared. So in declaration section, we declare the variables, arrays, and all the functions. And in the executable part, it is a set of statements to perform, which performs the task. Executable part will hold the statements which performs the task, and there should be at least one statement in executable part. In executable part, there should be at least one statement. Okay, so this is about main function. And next is the braces. So in main functions, it is having the braces here. So this is called open brace, and this is the close brace. So let us see this braces. So every C program uses a pair of curly braces. So these are called curly braces. Okay, the left braces indicates the beginning of the main. So this left braces indicates the beginning of the main function, and the right braces indicates the end of the main function. So this indicates the beginning of the main function. This indicates the end of the main function. That is about braces. And this is a user-defined functions. So in user-defined functions, these are called subprograms. User-defined functions are the subprograms, and these are written by user. Hence, the name user-defined functions. So these functions are written by the user. So because that the name is user-defined function. So this is a part. This is a user-defined function. That is a part 3. And next we will see the steps involved in executing a C program. Okay, see basically there are 5 steps are there to execute a C program. The first step is creating a program. Creating a program is the first step, and saving the program, it is with the .c extension. It is the second step, and then third step compilation, and the fourth step is linking the system library functions, and then executing, or we call it as running the program. So these are the total 5 steps in executing a C program. So here this figure illustrates the execution, how the C program will execute. So here it is the preprocessor. It includes the header files. It includes the source code. Okay, the compiler will take it as the input. .c file has the input, and then it creates one object file. Okay, this object file is given as input to the linker. It uses the library routines, and then the linker will execute the code, that is in the form of executable form.exe. So this is the total explanation of executing a simple C program. So here let us see how this process is done. So in first step, the source code is entered using a text editor in a file with a .c extension. So in first step, here we create a source file with a .c extension. It consists of preprocessor directives and functions. So it consists, or it contains, preprocessor directives. Okay, and functions. It also includes functions, preprocessor directives and functions. So in step 2 what happens here? The preprocessor extends the hash defined directive and adds the hash include files. So here it includes the hash include files. The preprocessor will add hash include files to the source code. And in step 3, the compiler produces an intermediate object code with a .obj extension. So this is the intermediate code. .obj is the intermediate code. Object code is called intermediate code. Compiler will create a intermediate code. Okay, and .obj is the extension for the object file. And step 4, the linker adds the relevant library routines and produces an executable version with .exe extension. So here the linker, it uses the library routines and it generates executable code. It uses the object code and it includes the library routines and it will generate the executable code. So this is steps which produces or which executes a simple C program. In total 4 steps, the process is done here. Okay, so this is for today class. Thank you to everyone.